David Smith here with one more flipped classroom math lesson. 3 tips before we start. First, remember that you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to jot down some notes or write down some questions for our next class. Lastly, you can turn on the captions so you can read my words go by on the screen. In today's lesson, we're going to talk about how to use formulas for finding sums of arithmetic and geometric series. So let's check this out. There's a bunch of formulas here, and we're just going to use these formulas and a little critical thinking to find some sums. And these formulas are in your formula booklet, so you don't need to memorize them. You just need to know how to use them, not always straightforward. So let's take a look at these formulas. So Sn means the sum of all the terms up to n. So if this was n6, we'd be summing up all the terms from the first term to the 6th term, and so on. So we have 2 formulas for each type, arithmetic and geometric. And so our first one for arithmetic is n over 2 times u1 plus un. So this is one where if you know the first term and the nth term for the sequence that you're summing, the series that you're summing, then you can plug in here and you can get your sum. Remember, the sum is the total of all the terms added up. Alternatively, you can use n over 2, same term here, but now you're adding the first term plus n minus 1 times the common difference. So if you have the common difference and you know the first term, you could do it in this way as well. So these are your 2 go-to formulas for summing up arithmetic series. Now let's take a look at geometric, a little different. Now we have Sn equals the first term, u1, times r to the n, and then subtract 1. So it's not r to the n minus 1, it's r to the n subtract 1. So that term is on top of just simply r minus 1. Now this is kind of interesting. You can just switch these 2 terms here to get the second sequence. So this one is just u1 times 1 minus r to the n over 1 minus r. So you have a couple options to use for each type of sequence that you want to sum up. So when you're prompted to find the sum of a series, your first question should be, is this arithmetic or geometric? Because you've got to use a correct formula to find that sum. So let's do some examples. All right, let's do an example. Here is a series. It goes from 1, 5, 9, ... all the way up to the 8th term, or u8. So first, we need to figure out whether this is arithmetic or geometric. So pause the video for a second, think about that. All right, if you notice that we're adding 4 each time, you'll realize that this is arithmetic sequence, so cool. Now, look at what we have and what we know, and figure out which of those 2 formulas works for finding the sum of this series. All right, so this is going to be the formula that uses twice u1 and n and the common difference. We don't actually know the last term, although we could figure that out, but we're going to plug into this one because we have all the variables. So check this out. Why don't you write down the values of n, d, and u1. All right, so here they are. u1 is 1, first term. N is 8. We have 8 terms total. And of course, our common difference is 4. So now we're ready to do the plug-in step on this formula. So go ahead, pause the video, and do that. All right, so here's my plug-in step. I know my n is 8, so I put 8 in for n, where it shows up twice in the formula. And then I have 2 times u1. u1 is just 1, so 2 times 1, plus n minus 1 times our difference. So there's my plug-in step. I urge you to do one like that shows everything. That's worth points when I grade tests and quizzes. So now, pause the video and work that out and find the sum of the first 8 terms of this series. All right, so I just worked my algebra on down, crunched my numbers, and I got 120 for the first 8 terms of this arithmetic sequence. All right, so take a look at this series. Is that geometric or arithmetic? Pause the video real quick and think for a sec. So this one is definitely geometric, and one of the giveaways is that we have a power. We have n in our power. So this is going to be multiplying by 3 repeatedly. The first term is going to be minus 2 times 3 to the 1, or 3. The second term is going to be minus 2 times 3 to the 2, which is 3 times 3, and so on. So our r in this case is 3. So now I want you to pause the video and take a look at this expression for our series and determine how to do the plug-in step with either one of those sum of a geometric series formulas. All right, so I chose to use this formula with the r to the n minus 1 over r to the 1, with u1 sitting out here. I did need to figure out what u1 was. Pretty easy. That's just when n is 1, is dictated by this. So it's just 3 to the 1 times negative 2, which gives us negative 6 for my u1. And then I'm doing r, which is 3, to the 15th to find the series, all the way up to the 15th term of our series. So 3 to the 15th minus 1, and then I just pulled my r down, which is just my 3 minus 1 there. So now go ahead and pause the video, crunch the numbers, and find this sum. All right, let's see how you did. So what I chose to do is evaluate these two numbers here. 3 minus 1 is 2, and then divide negative 6 by 2, and that reduces down to a minus 3. So I get rid of my fraction right away. It's kind of convenient. And then I did my 3 to the 15th minus 1. That's a ginormous number, 14,348,000, blah, blah, blah. Don't round this yet. Do your rounding at your answer. So check this out. Here we go. The sum of this series is minus 43,046,718. All right, here is another series. Starting on 6, go to 12, go to 18, go to plus, dot, 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 dot. And we're all going all the way up to the 7th term. So what I want you to do now is pause the video, look back over your notes, figure out which type of series this is, pick a formula, solve that, take that all the way through to the sum, because I think you can. All right, so this is an arithmetic sequence. We're adding 6 each time. We're going to go all the way up to S7. We don't actually have to figure out what S7 is because we have what we know to use this formula. We have our difference, we have our first term, and we know how many terms. We go all the way to the 7th term. So I picked this formula. There it is reproduced for you. I'm showing you what my values are. N is 7, U1 is 6, and our difference is 6 for that. So here is my raw plug-in step. I didn't do any math. I just inserted these numbers where they belong in the formula. Now I'm just going to crunch it on through, doing basically computational stuff, not really even algebra, and I get S7 equals 168. So make sure you understand and can do those steps. All right. Here is another one. 100, 50, 25, dot, 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 all the way to the 6th term. So I would like you to figure out what type of sequence, figure out which formula you want to use, do your plug-in step, and come back. Okay, let's see how you did. First thing, this is a geometric series. We're multiplying each term by 1/2 to get to the next term. So this sets the stage. Here's the formula that we need to use. The sum of the 6 terms of the series is given by that formula from a couple boards ago. So now here's my plug-in step for our particular series. First term times r to the n minus 1 over n minus 1. So now if you haven't already done so, I want you to simplify this on down and let's find the sum of the 6 terms of this series. All right, let's see how you did. So what I did in my first step is I dealt with my numbers on the outside of my more complicated term. So 1/2 minus 1 is negative 1/2. When you divide negative 1/2 into 100, you get minus 200. So that took care of the fraction. And then I also simplified this a little bit. 1/2 to the 6 is the same as 1 to the 6, which is just 1 over 2 to the 6. So now this parenthetical term is 1 over 2 to the 6 minus 1. I crunch my numbers. 2 to the 6 is 64, so this becomes minus 200 times 1/64 minus 1, which is negative 63 over 64. Crunch those numbers. I got all the way down to 196.875. So let's take a look at another one that's set up a bit differently. Notice how instead of adding terms, we're subtracting terms. So this still can be a sum. We're just adding up successive negative numbers. So we can still sum this series. So take a look at it, figure out whether it's geometric or arithmetic, figure out your formula, and do your plug-in step. All right, let's see how you did. Sequence is geometric. We're multiplying our first term by 2, by positive 2, each time. Negative 2 times positive 2 is negative 4, times positive 2 is negative 8. So even though our terms are negative, because we started with a negative first term, we have a positive r. So our r is 2, number of terms is 9, we're going all the way up to u9, and finally our first term is minus 2. So here's your type of series, here's your values for your plug-in step, Here is the plug-in step using the formula. Now, if you haven't already solved it, go ahead and work that math and find that sum. All right, I like getting rid of these numbers outside the parenthetical term. So again, what I did is I just did 2 minus 1. That's 1, so that just goes away. This fraction is over 1, so we can just get rid of that. So now I have minus 2. 2 to the 9th is 512. So I have minus 2 times 512 minus 1, which gets me minus 1022 for the sum of this series. Here's another one to practice. What I would like you to do is jot that down in your notes and pause the video and take it all the way through to the sum. See if you can do that, and then come back to the video and check how you did. All right, let's see how you did. Arithmetic sequence. We're just subtracting 8 each time all the way to the 7th term. Here's our values. We have U1 is 132, our difference minus 8, 7 terms, there's our n. So I'm going to use this form of the sequence, or the sum formula, the series formula. Sorry, I mixed those words up quite a bit. So we're going to get the sum of the first 7 terms of the series is n over 2 times u1 plus n minus 1 times the common difference. I crunch my numbers down here, and I end up with 756. Make sure that you can do this math. All right, let's look at some of the more tricky ones that you might encounter in the exercises or on a quiz or a test. So check this one out. Our series goes 1/8 minus 1/4 plus 1/2 minus something all the way up to the 12th term. So we want to find the sum of the first 12 terms of this series. So first off, pause the video, determine whether it's geometric, arithmetic, figure out which formula you're going to use, and do your plug-in step. Let's see how you did. Geometric sequence. Basically what we're doing is we're multiplying each fraction by 2 to get the next one, but not quite. It's by negative 2. So 1/8 times negative 2 is negative 2/8, which is negative 1/4. 1/4, negative 1/4 times negative 2 is positive 2/4, which is positive 1/2, and so on, all the way up to U12, the 12th term. So geometric sequence, our R, as we discussed, is minus 2. Our first term is 1/8, and finally, our number of terms is 12. So now I'm going to do our plug-in step here. The sum of the 12 terms of the series is first term times R to the 12th minus 1 here, and over R minus 1. Now I want to call your attention to one thing here. You need to put parentheses around your negative 2 in some calculators. Otherwise, what it will do is it will just do 2 to the 12th power and then throw the negative on there, which in this case would work with the 12th power, but if it's an odd power, it's not going to work. It will give you the wrong sign of this exponential term. So now, if you haven't already done so, I want you to crunch the numbers and find out what the sum of the first 12 terms of this series is. All right, let's see how you did. I just crunched my numbers. This time I did it a little differently. I didn't want to mess around with 1/8 over minus 1/3 or minus 3. You could do that if you like. So what I instead did was I crunched this parenthetical term. This gives me 4095, and then I have that times my 1/8 divided by negative 3. Get out my calculator, crunch these numbers. I get the sum of the first 12 terms of this series is 170.625. One last sum. Take a look at this series and figure out A, whether it's geometric or arithmetic, and then figure out what you need before you can start plugging into a formula, because this one takes an initial step before you can do that. All right, if you figured that this was a geometric series, you're right. We're just multiplying each term by 1/2. So the top just stays the same, and the bottom's getting multiplied by 2 as we go all the way up to 256. Now, to understand how to use the formula for a geometric series, you need to know the number of terms. And we don't. We have this ellipsis in here. We know we've multiplied by 1/2 a bunch of times to get all the way up to here. So we had a trick from a couple previous lessons where we can find the number of terms if you know the first term, the last term, and R. So go ahead and do that. All right, let's see how you did. This one's a little bit tricky. There's a lot of steps just to get to N. Okay, so watch how this goes. What I did is I did my plug-in step there, just using my geometric formula to find the nth term. So we know this is the last term. It's going to be the first term times the r to the n minus 1. We just don't know what n is. So what I did is I divided 5/4 away from the right side. That gave me 4 over 256 equals 1/2 to the n minus 1. I'm just bringing that down. 4 over 256 is 1 over 64. Bring that down. Now so here's the thing. When I have a number to a power that I can't just take the root of because I have a variable in there, I just need to set the other side of the equation so that the base is the same. So I have a base of 2 to some power, so I need to write 64 as a power of 2, and I'm happy about that because 64 is just 2 to the 6th. I can just do that. So now I have 1 over 2 to the 6th equals 1 over 2 to the n. So now I can just simplify this down quite a bit by just saying 6 equals 2 or equals n minus 1, which gives me 7 for my n. So this is basically just doing algebra with exponential functions. If you need some help from that, I do have other videos that talk about how to do this. Okay, so now we're back to finding the sum of our series. I changed this to, now we know what the number of terms we have. This is the 7th term, U7. So go ahead and do your plug-in step with your geometric series sum formula. Work that through, come back when you have an answer. Let's see how you did with this one. So I went ahead and did my plug-in step there with my 1/2 for my r, my first term, and my number of terms there. Working that through from the plug-in step, I've manipulated my fractions here. 1/2 to the 7th is 1 over 128 minus 1. I have my minus 1/2 on the bottom. I took care of these two by dividing through 5 over 4 by minus 1/2, which gives me minus 5 over 2. Combining these guys, I get minus 127 over 128. Then I can just multiply through with my fractions. This gives me this answer of 635 over 264. This is an exact answer, so if you're prompted for an exact answer, don't go to a decimal that gets rounded. But if you did, there is the decimal with rounding. Now that you've watched the video, jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch the portions of the video that challenged you the first time. If you enjoyed the video, please click like. If you'd like to help me grow my YouTube channel, please click subscribe.